The world which the theory of relativity presents to our imagination is not so much a world of things in motion as a world of events. It is true that there are still particles which seem to persist, but these are really to be conceived as strings, connected events, like the successive notes of a song. It is events that are the stuff of relativity physics. Between two events which are not too remote from each other, there is, in the general theory as in the special theory, a measurable relation called interval, which appears to be the physical reality of which depth of time and distance and space are two more or less confused representations. Between two distant events, there is not any one definite interval, but there is one way of moving from one event to another, which makes the sum of all the little intervals along the route greater than by any other route. The collapse of one all-embracing time in which all events throughout the universe can be dated must, in the long run, affect our views as to cause and effect, evolution, and many other matters. For instance, the question whether on the whole there is progress in the universe may depend upon our choice of a measure of time. We naturally interpret the world pictorially. We imagine that what goes on is more or less like what we see. But in fact, this likeness can only extend to certain formal logical properties expressing structure. So that all we can know is certain general characteristics of its changes. Assuming the utmost that can be claimed for it, it does not tell us what it is that changes, or what are its various states. It only tells us such things as that changes follow each other periodically, or spread at a certain speed. On that part of the mind, the abstract character of our physical knowledge may seem unsatisfactory. From an artistic or imaginative point of view, it is perhaps regrettable. Abstraction, difficult as it is the source of practical power. The physicist who knows nothing of matter except certain laws of its movement, nevertheless knows enough to be able to manipulate it. All working through whole strings of equations, the symbols stand for things whose intrinsic nature can never be known to us. What we know about matter, abstract and schematic as it is enough in principle to tell us rules according to which it produces perceptions and feelings in ourselves. And it is upon these rules that the practical uses of physics depend.